Today we're going to talk about how to solve a quadratic equation using the square root method. So in the last section we talked about how to solve a quadratic equation by factoring, and at the end we mentioned that not every polynomial or not every quadratic function is going to factor, and if it doesn't factor, there has to be another way for us to solve it. This is a method that works in specific times and doesn't always work, just like the factoring method doesn't always work. But the goal here is to isolate the square root part so that we can solve almost in a similar manner to how we solved equations in the first unit. So here we go. Our goal when we are solving using the square root method is to isolate the squared term. Now that could simply be x squared, or it could be something like x plus 4 quantity squared. This is the term that's being squared. This is the term that's being squared. So our ultimate goal is basically to solve for the squared term so that we have something squared equals a number. Everything else is on the other side. Once we've done that and we have something squared equals a number, we're going to take the square root of both sides of the equation. Then we're going to solve for the remaining variable. And remember, just like when we solved by graphing, just like when we solved by factoring, there can be 2, 1, or 0 solutions, right? There could be 2 solutions, there could be 1 solution, or there could be no real solutions. In the real number system, as long as you probably have been learning math, we have told you that you can't take the square root of a negative number, that it doesn't work. And in this section, when you get to a point where you're being asked to take the square root of a negative number, that is a hint that there is no real solution to this particular type of problem. In Algebra 2, you're actually going to learn about how to do this with imaginary numbers, something called imaginary numbers. We use the letter I to represent that. So for example, if I was supposed to take the square root of negative 81, this would insinuate that there's no real solution. But what this would actually be is it would be 9i. But we'll get back to that. This is not something you're going to be assessed at this level, just to keep that in mind when you're moving forward with math. So the goal is to isolate the squared term, then to take the square root of both sides, and then to solve for the variable. So let's look at this example here. Our first goal is to isolate the squared term. So I'm going to add 49 on both sides. So I'm going to have 16x squared equals 49. I still haven't isolated the squared term. I need to get x squared by itself, so I'm going to divide by 16. It's okay that 49 and 16 do not evenly divide. So I have officially accomplished our first goal, which was isolate the squared term. Our second step says to take the square root of both sides. When I take the square root of x squared, what times itself is x? What times itself is x squared? That's going to give us x. Anytime you are taking the square root of both sides, you should have a plus or minus symbol there. And you can think of this as the same thing as the square root of 49 over the square root of 16. So that's going to be 7 over 4. The square root of 49 is 7. The square root of 16 is 4. So this final answer is going to be plus or minus 7 over 4. So isolate the squared term, take the square root of both sides, don't forget your plus minus, and then solve for the remaining variables. Let's look at some more examples. On number 1, the squared term is already isolated. I just have x squared equals 36. So I'm going to move on to my second step, which is to square root both sides. Don't forget your plus minus. What times itself is 36? Well, that's 6, so our final answer, plus or minus 6, or you could rewrite this as negative 6, 6. Number 2, ask yourself, what is the squared term? The squared term is x squared. What is currently preventing x squared from being by itself? This plus 7. So we're going to subtract 7 on both sides. That's going to give us x squared equals 0. We have successfully squared or isolated the square term, so now what? Now we square root both sides. Don't forget your plus minus. The square root of 0 is just 0. Plus or minus 0, that doesn't really make any sense, right? 0 is neither positive nor negative, so there's only going to be one solution here, and that one solution is 0. And if you look up and you plug in 0, that makes sense. 0 plus 7 does equal 7. That makes sense. Similarly over here, negative 6 squared does equal 36. That makes sense. And 6 squared does equal 36. So you do have the ability to go back and check your answers. Okay, for number 3, our variable is already isolated, so we can square root both sides. Uh-oh, though. We are being asked to square root a negative sign. That means that there is no real solution. That is a totally acceptable answer. In Algebra 2, what you'll say is that x is equal to plus or minus the square root of negative 81. And to get rid of that negative sign, what you do is you just stick an I right in front of your radical, insinuating that this is an imaginary solution. And then we know the square root of 81. The square root of 81 is 9. So just looking ahead in future classes, you're going to say that the solution to this quadratic is plus or minus 9i. In this class, you are more than welcome to stop here and just say there is no real solution since the inside of the square root is negative. Why don't you go ahead and pause the video and try and work through number 4 on your own. Remember, isolate the squared term, square root both sides, don't forget the plus or minus, and then solve for the variable. Okay, so hopefully you paused the video and took the time to do this. I'm going to subtract 48 on both sides. That's going to give us 100x squared equals negative 49. I'm going to divide by 100, so x squared equals negative 49 over 100. I have isolated the squared term, so now I need to square root both sides. So x is going to equal plus or minus the square root of a negative number. That means no real solution, which is the acceptable answer here. If you wanted to take it a step further, the square root of 49 is 7. The square root of 100 is 10. So this is also plus or minus 7 over 10i. If you wanted to find the imaginary solutions. Again, that's not going to be required at this level, but it will be required in future classes. So in all of the examples that we just did, the squared term was simply x squared. We had to isolate x squared, then we square rooted both sides, and then we solved. But the question that should arise is, well, what happens if the squared term is more than just x? If it's not just x squared, but it's something slightly different. How do we simplify a problem like that? So you're going to go through the same process. You're still going to isolate the squared term, just now that might look a little bit more complicated. You're still going to isolate that term that is being squared. You're still going to square root both sides, and don't forget the plus minus symbol. But now, just like you did when you were factoring, you're actually going to make 2 different equations, one for the positive version and one for the negative version, right? The plus and minus. And you're going to solve each separate equation, and then you're going to write your final answer using set notation. So here we go. I'm going to put a box around my squared term here on this example. If I want to isolate that, what do I need to do? I need to add 2 on both sides. So I'm going to have x minus 1 quantity squared equals 4. Now I have isolated my squared term, so I'm going to square root both sides. So I have x minus 1 equals plus or minus 2. Now we're actually going to split this into 2 different equations. This is saying that either x minus 1 is negative 2 or x minus 1 is positive 2. So we're splitting that into 2 separate equations, one for the positive and one for the negative. And then we're going to solve. If I add 1 here, this is going to give me x equals negative 1. If I add 1 here, this is going to give me x equals 3. So my 2 solutions for this example are negative 1 and 3. And we could check that. We could plug that back in. Negative 1 minus 1 squared is positive 4 minus 2. It does, in fact, equal 2. 3 minus 1 is 2. Squared is 4. Minus 2 does equal 2. So it does work if we plug it back in. So looking at number 5, step 1, isolate the squared term. It's already isolated. What do we do next? That's right. We square root both sides. So x minus 5, the squared and the square root, those are inverse operations. The square root of 16 is positive and negative 4. Then we're going to split into 2 equations. X minus 5 equals negative 4. X minus 5 equals positive 4. And we're going to solve. Add 5 to both sides gives me 1. Add 5 to both sides gives me 9. So the 2 solutions here are 1 and 9. why don't you go ahead and pause the video and work through 6 and 7 on your own. See how far you can get. Remember, you need to isolate the squared term first, and then unpause the video and see how you did. All right, hopefully you did, in fact, pause the video. To isolate the squared term here, I'm going to divide everything by 2. 2 divided by 2 is 1, so this is going to give me 2x plus 1 quantity squared. Half of 128 is 64. My squared term has been isolated, so I am going to square root both sides. That's going to leave me with just 2x plus 1 equals, the square root of 64 is positive and negative 8. Split into two equations. 2x plus 1 either equals negative 8 or 2x plus 1 equals positive 8. And I'm going to solve here. So I'm going to subtract 1. That's going to give me 2x equals negative 9. I'm going to divide by 2. That's going to give me negative 9 over 2. I'm going to subtract 1. 2x is 7. I'm going to divide by 2. X is 7 over 2. Just because the answer contains fractions doesn't mean that it's automatically wrong. I know a lot of you assume that. So I'm going to write my two final answers, 9 over 2, negative 9 over 2, and positive 7 over 2. On number 7, the squared term is already isolated, so we can square root both sides, and that's going to give us x plus 3 equals plus or minus the square root of 18. Now, 18 doesn't evenly square root. There's no integer that when I multiply it by itself gives me 18. However, we did learn earlier, and you can go back and check out this video if you need to, how to simplify a radical, and we do expect that your answers are as simplified as possible. So what multiplies to be 18? 2 times 9. What multiplies to be 9? 3 times 3. This is a square root, so I'm looking for pairs. So I'm going to keep this the same over here. X plus 3 equals plus or minus. I can take a 3 out, and I didn't use this 2. This 2 right here. Now, I still have an isolated x. I need to subtract 3 on both sides to do that. And when I subtract 3 on both sides, I'm just going to stick this 3 in front of the plus or minus symbol. I'm going to add set notation, and I'm going to stop there. So remember that math builds on itself. The things that we learned in previous chapters still come into play, still help us simplify, and still help us get to that final answer. So to solve using the square root method, again, we isolate the squared term, we square root both sides, not forgetting our plus or minus. We make two equations, and we solve the remaining equations. So why does this method not always work? At the beginning of this video, I said, just like when we solve by factoring, that there are times where you can't possibly use this method. This method is great when it works. But when doesn't it work? Let's talk about that briefly, and then we'll wrap up. So if you look at this example here, x squared minus x equals 5. If you tried to isolate the squared term, we sort of have a problem. I could add x to both sides. But what happens now? If I try and square root both sides, I have an x inside here. This isn't a number. I'm not going to be able to manipulate this. There's no way that I'm going to be able to get all of my x's on one side and all of my constants on the other side. So the square root method will not work on a problem like this. So the key thing to remember when you're looking to use the square root method, you're looking for something where you either already have a quantity squared or where you don't have a bx term. What I mean by that is you could solve using square roots here, you could solve using square roots here, but you couldn't solve using square roots here. When we have problems like this, which doesn't factor, and I can't use the square root method on, we're going to need another method to solve. And that's what we're going to talk about in the next two sections. We're going to talk about completing the square, and we're going to talk about solving using the quadratic formula. But for right now, it's really important for you to recognize when can I use the square root method and when can I not. So, recapping this section, solving a quadratic function using square roots, isolate the squared term, square root both sides, don't forget your plus minus, solve for the remaining variable, and make sure you write your answer in appropriate notation. Go ahead and post your questions under this video or write them down, and I look forward to supporting you on this. Thanks for listening.